Hello students, so I'm going to teach you today a very important lesson in ordinary level. So in the grade 10 we are studying this lesson, quantification of elements and compounds, right? So I will teach you the most important parts of the equations in this lesson. So first one over here is relative atomic mass, which is AR. A means atomic, R means relative, right? So what do you mean by relative atomic mass? It's the mass of one atom of the element relative to 1/12 of the mass of a carbon 612 atom, right? So let's see it by the equation. So we are measuring the mass of an atom of the element relative to the 1/12 of the mass of a carbon 612 isotope, right? So we have to divide the mass of carbon 612 isotope or atom by 12. So it is, we can give the name as atomic mass unit, AMU, right? Okay, then we have to divide the mass of an atom by that number, right? So we'll see an example. Here they have given us the mass of oxygen atom, which is the 2.66 into 10 to the power minus 23 grams. And the mass of carbon 612 atom is also given. It is 1.99 into 10 to the power minus 23 grams. So let's write the equation here. So the relative atomic mass of oxygen equals mass of oxygen divided by 1/12 of the mass of carbon 612 isotope or atom. Here, so we can substitute the values that they are given. Then we can divide those numbers and get the final answer as 60, right? So we'll see another example. Find the relative atomic mass of potassium if the mass of the potassium atom is 6.476 into 10 to the power minus 23 grams and the mass of carbon 612 isotope is given 1.99 into 10 to the power minus 23 grams. Okay. First we have to write this equation, okay? So mass of the atom should be divided by AMU or the atomic mass unit. So the mass of atom is 6.476 into 10 to the power minus 23 and the 1/12 of the mass of carbon 612 isotope is this value. So simply we can divide these values and get the answer as 39. Then we'll move to the next part of this lesson. It is the relative molecular mass, MR. So what is the definition of it? It's the sum of the relative atomic masses which we have studied previously. So we'll get it. So we can write the equation here. Relative molecular mass equals sum of relative atomic masses of all the atoms in the molecule. So we'll get a molecule here. So molecule is carbon dioxide, CO2. Relative molecular mass of carbon dioxide equals the sum of relative atomic mass of carbon, which is the 12, and 2 oxygens. That means oxygen relative atomic mass is 16. There are 2 oxygens, therefore 16 should be multiplied by 2. Okay. So finally we will get 44 as the relative molecular mass of carbon dioxide. Then the next equation, the question, find the relative molecular mass of ammonia. So they have given the relative atomic mass of nitrogen and hydrogen. So nitrogen, it is 14 plus there are 3 hydrogens. That means 3 into 1. So 14 plus 3, it is 17. Therefore relative molecular mass of ammonia is 70. So for the ionic compounds also we can get the same value for relative molecular mass. So we can get the ionic compound like sodium chloride. So we have to add the relative atomic masses of sodium plus relative atomic mass of chlorine. Okay, so we can get the sum of these values and finally we will get as 58.5 as the answer, right? So next concept is Avogadro constant, which is symbolized by capital L. So what do you mean by Avogadro constant? So it represents the number of atoms, molecules or ions in 1 mole of a substance, right? So in a 1 mole of these substances we have Avogadro number, which is 6.022 into 10 to the power 23. Okay. Now the next concept, mole and the molar mass, right? So what do you mean by a mole? 1 mole of any substance contains 6.022 into 10 to the power 23 basic units, okay, which is the Avogadro number of atoms, molecules or ions. So molar mass of any element or compound is the relative atomic mass or molecular mass expressed in grams per mole. So previously we have studied how to get relative atomic mass and molecular mass. So it is having no units, and here if we indicate that value in grams per mole, we can say it is the molar mass of that element or compound, right? So we'll derive an equation for moles, right? So the moles or the amount of substance is symbolized by simple N and mass is symbolized by simple M. Molar mass capital M, right? So we will have this equation, simple N equals simple M over capital M. You can easily remember this one as simple M always come first, then the capital M, right, which is the molar mass. Okay, N amount of substance which is measured in moles, simple M is the mass of the substance which is measured in grams, and capital M which is the molar mass measured by grams per mole, right, per mole here. So we'll see an example. Here we have to use the equation N equals M over M. They are asking calculate the number of moles, which is the simple N, in 46 grams of sodium. So 46 means mass of the element, simple M. Okay, we know simple M, and then they have given the capital M value also. We have to find the simple N, right? Now we know the equation, which is N equals simple M over capital N. Now M value is how much? Mass is 46 grams. 46 grams. Molar mass is 23 grams per mole. They have given it, right? So we can get the number of moles by dividing mass by molar mass. Grams to gram cancel and per moles goes up and it will become moles. Finally, the answer is 2 moles, which is 46 divided by 23, right? We'll see the next question. Find the mass of 0.5 moles of glucose, which is C6H12O6. So they are asking simple M. So they have given simple N moles, and they also given us molar mass capital M, which is 180 grams per mole, right? So we have to substitute here the equation what we know. What is that? N equals M over M, right? So here, but they are asking what? Simple M. So we have to subject the simple M over here. How we can subject simple M? We have to multiply simple N by capital M, right? So we will get the equation like this. So N equals 0.5 moles and M equals 180 grams per moles. So finally you will get the answer as 90 grams. So there are 90 grams of glucose in 0.5 moles of glucose. Then we will move to the next question. How many moles are there in 100 grams of water, right? So here they are asking N. So simply we can write the equation. We know N equals M over M. Mass is 100 grams. Molar mass is 18 grams per mole. So finally, when we divide these two numbers, we will get 5.56 moles. Okay. What is the last question? Determine the mass of 3 moles of calcium carbonate. So they are asking mass. So how we can subtract the mass? So we have to multiply N by capital M like this. So mass equals number of moles 3 and the molar mass is 100 grams per mole. So finally you will get the mass as 300 grams. There are 300 grams in 3 moles of calcium carbonate. So that's what we have to know in this lesson. Thank you all.